Is the future of computing quantum? A question that is not as far-fetched as it might have seemed a decade ago. As we embark on a journey through time, let's delve into the evolution of quantum computing and peek into what the future holds. The year 2019 marked an important milestone in the field of quantum computing. Google, a pioneer in technology, announced an achievement that shook the scientific community: the attainment of quantum supremacy. This breakthrough ignited a spark that led to increased research and investment in quantum hardware and algorithms. Following this remarkable feat, the noisy intermediate-scale quantum, or NISQ era, dawned upon us. While not yet fully fault-tolerant, these NISQ computers hold the potential to solve real-world problems and expedite applications in fields as diverse as optimization, cryptography, and material science. The focus of research then shifted slightly to hybrid quantum classical systems. These systems unite the best of both worlds, with quantum and classical computers working hand in hand to solve complex problems more efficiently. Alongside these developments, the field witnessed progress in quantum error correction. New codes and techniques emerged, paving the way for more reliable quantum hardware and edging us closer to achieving fault tolerance. As we stand at the threshold of 2024, the future of quantum computing looks promising. Researchers are expected to make significant strides in quantum error correction, refining existing codes and exploring new ways to reduce error rates in quantum hardware. The coming year is also likely to see a rise in quantum hardware diversity. From ion trapping and photonics to NV-diamond, superconducting qubits and silicon-based qubits, various platforms will see substantial progress, each with its unique advantages and challenges. Quantum networking and long-distance entanglement are set to play a crucial role in the future of quantum computing. Advancements in quantum communication protocols and infrastructure are anticipated in 2024. We can also expect the emergence of application-specific quantum computers. These specialized computers, tailored for fields like drug discovery, materials science, and cryptography, will make quantum computing more accessible for practical purposes. An exciting development to look forward to is the integration of quantum computing and artificial intelligence. This convergence will enable more advanced machine learning algorithms and applications, leveraging quantum resources for exponential speed-up. In conclusion, the year 2024 holds great promise for the field of quantum computing. While the dream of a fully fault-tolerant quantum computer may still be a few years away, every day we are taking steps toward making this dream a reality. The future of quantum computing is not just a question anymore. It's a journey of discovery that we are all part of.